Okay, good morning, students. Now I am going to start the class, right? Uh, you can write whether my voice and board is it clear or not. And if it clear, then I will start the class. I will not wait. I will not waste the time. Okay, right. I am going to start. You give the information. Is it clear? Voice and board. Today I am going to explain about the particle nature of light. We know that light has the particle nature, right? That particle nature of light I am going to explain, and that light has the wave nature, and light also has the particle nature. In the previous class we discussed about the Einstein photoelectric equation, right? That is a very important topic we discussed in the previous class. Einstein photoelectric equation. What is Einstein photoelectric equation? H nu is equal to phi naught plus Ke max. That is the Einstein photoelectric equation. That incident photon energy used in two ways. Now the today's topic is particle nature of light. Particle nature of light. Light also has the particle nature. Light has the wave nature and light has the particle nature. That particle nature of light I am going to explain now. For that, okay, good. Sushmita, Sara, Puneet. Okay, I am going to start. Thanks a lot to all. Right till half an hour onwards, you are waiting for my class. And now, that is the particle nature of light. The light quantum has according to quantum theory, right? That light quantum, that means light travel in the form of energy packets. But energy packets are called as quantums, right? And each quanta has energy h nu, and quanta is also called as the photon. That light quantum or the light photon has energy h nu and momentum h nu by c. We derived yesterday, right? According to quantum theory, energy of photon is h nu and momentum of photon is h nu by c, right? Now the light quantum has energy. Light quantum has energy h nu and momentum h nu by c and momentum h nu by c. Hence, it is associated with it is associated with the particle called as the photon. So light has particle nature. What is this? What this sentences indicates? I will explain clearly. The light quanta has energy h nu, and the light quanta has momentum h nu by c. Hence the light quanta is associated with a particle. That particle is called as the photon. Right? Why we are considering the light quanta as particle? Because generally you know that one particle can have the momentum. Generally the particle has the momentum, mass into velocity, right? And the particle, if it will travel with some velocity, it is also has the energy. That means we know that the particle has the momentum and energy, right? Particle has the momentum and energy. If particle moves with certain velocity, it has energy and it is also has the momentum. But when you consider the light, for the light we studied that we not till now we not don't know about the mass of the light. Right? The light has energy, yes, we can accept. But the light also has the momentum. We derived the formula, right? Then light has the energy and momentum means, okay, and this light is also interacting with the particles in the medium, right? When the light falls on the metal surface, right, that light photons energy packets, they are interacting with the electrons in the metal, and they are making the electrons to come out from the metal surface. Generally the matter will interact with the matter. Matter will interact with the matter means one particle will collide with the other particle, and it applies the force and it supplies the energy, like that we know these all things. But here the light also interacting with the matter. Light interacting with the matter means light is also made up of particles. Light is interacting with the matter. Generally particles interact with the particles. Matter means particle. Matter means particles. Material is made up of particles, but the light is the energy. But this light is also interacting with the particles, right? It is emitting the electrons. Electron is a particle. Light is interacting with the particle means light is also made with the particles. Light is also has the particle nature, right? And the light has, why we are telling that the light has the particle nature? Because the light quanta has energy, and the light quanta has momentum. That means light is made up of particles. Actually previously in the last chapter, while discussing about the wave optics while discussing about the wave optics we consider that the light is a wave. We used the principle of superposition of waves, right? And based on the wave nature we explained the interference and diffraction also, right? And now one thing you should remember, that light quanta has energy and momentum. That's why it is associated with a particle. Generally for the momentum is for particle. The light is also has the momentum, and light also has the particle nature, right? And now let us discuss some important point. This is very important for the 3 marks previous question. Okay, very important. That is, summarize the summarize the photon picture of electromagnetic radiation. Electromagnetic radiation. This is our topic. Very important. Summarize the photon picture of electromagnetic radiation. This photon picture we have to explain. How? Then I will give some points that are very easy to understand. With these points you have to write in the exam if it will come, right, in the exam. That is, we know that the radiation, if you have the doubts, you can write in the chat box. Radiation interact with the matter. This indicates this indicates radiation is radiation made up of particles, radiation made up of particles called as photons. This is the first point. Okay, what is this? Radiation interact with the matter. Do you know this? Radiation is interacting with the matter. This is the radiation. Radiation means light. This is the radiation. It is interacting with the matter. This is the matter. Metal is the matter. It is interacting with the matter. Okay, that means generally what happens? Matter interact with the matter. Particles interact with the particles, but the light is interacting with the electrons. That means light is also has the particles, particle nature. Then that particles are called as the photons. This is assumption, hypothesis, right? Then this light has the particle nature. This particle is interacting with the electron and making the electron to come out. This is the first point. Radiation is interacting with the matter. Means radiation is also made up of particles. That particles are called as photons. And the second point is that each photon, okay, radiation is made up of particles. This is the radiation. It is made up of particles. This radiation light has the particle nature. But each particle is called as the photon or the quanta, right? Then this is the radiation. This radiation is interacting with the matter. That's why we are telling that radiation is also made up of particles. That particles are named as photons. And each photon has how much energy? Tell me. Each photon has energy. Each photon has energy h nu and momentum. And momentum h nu by c. H nu by c. Where h is the Planck's constant. Is the Planck's constant. And c is the speed of light. Nu is the frequency. Okay, speed of light or the radiation. And this is the second point. In the summarize the photon picture of electromagnetic radiation. Light is made up of photons. That photons properties I am explaining it here. Okay, photon properties. And the next one is the third point. All the photons, all the photons, all the photons of light of particular frequency, light of particular frequency, light of particular frequency has same energy and same momentum, same energy and same momentum. Whatever it may be the, whatever it may be the intensity of light, whatever it may be the intensity of light. What is the meaning of this? Okay, all the photons of light of particular frequency has the same energy and same momentum, whatever it may be the intensity of light. That means all the photons of particular frequency means I will explain. I'm going to erase, you take the screenshot. More 2 points are there. I'm going to erase total. I will explain the third point, don't worry. What you are telling it here in the third point. All the photons of particular frequency means frequency is constant. All the photons of particular frequency, right, have the same energy. same energy. If the frequency is constant, then energy is also constant. Is it right? Because energy depends upon h and nu. Nu constant, automatically energy constant. Right? And momentum. Momentum is what? What is the formula for the momentum? Momentum formula is h nu by c. Right? Nu and c is constant. Nu is constant, and automatically momentum is also constant. That means all the photons have the same energy. H nu constant. Momentum also constant. Momentum also same. Energy same. Momentum same. All the photons have the same energy, same momentum. When if the frequency is constant, means all the photons of light of particular frequency has the same energy and same momentum. If the frequency is constant, then every photon has the same energy and same momentum. If frequency is constant, then energy and momentum also constant. This is the point. Next, fourth point I am going to explain. The fourth point is that photons are electrically neutral. These light photons are electrically neutral. They are not have any charge. Photons are electrically neutral. Photons are electrically neutral. Photons are electrically neutral means they are not deflected in the electric and magnetic fields. They are not deflected in electric and magnetic fields. Okay. Generally, the charged particles will be deflected in the electric and magnetic fields. But the photons, light is an electrically neutral. That's why it is not deflected in the electric and magnetic fields. When the light passes in the electric field or the magnetic field, it cannot deflect it. Means electric field not applies the force on the photons, and magnetic field not applies the force on the photons, and it will not change the direction of motion of particles. And the next point is fifth point I am going to explain. It is the last point. In photon particle collision. In photon particle collision. In photon particle collision, total energy and momentum. In photon particle collision, the total energy and momentum are conserved. Are conserved. Okay, right. What is the meaning of this one? Where the photon particle collision is occurring? Can you give any example? Anywhere have you learned that the photon is collide with the particles? Right. When the light is allowed to incident on the metal plate, right? This is a metal plate. This metal plate has electrons. Then the one photon is collide with the one electron, and it is supplies its for total energy to the electron. In this case, law of conservation of energy is obeyed. Then H nu is the photon energy. Photon particles are collide. Photon and electron is collide with each other. Electrons are there in the metal plate, and photons and electrons are collide. In this law of conservation of energy and law of conservation of momentum is obeyed. Right? Energy is conserved and momentum also conserved. Energy and momentum is conserved means constant. Incident energy is h nu that can be used in two ways. Partly used to come out from the metal surface, that is a work function, and the remaining is used as the maximum kinetic energy. Right? Then that is only Einstein equation. That is h nu is equal, we write as phi naught plus T max. Right? The incident energy is used in two ways. That is a partly used to come out from the metal surface, and the remaining energy used as maximum kinetic energy. Okay, these are the summary of the photon picture of electromagnetic radiation. Just simply properties, right? Okay, and it was very simple that I will revise them within short period. Okay, and the first point is that in the summary, the radiation is interacting with the matter. That's why the radiation is made up of particles. They are called as the photons. And the second point is called as the each photon has energy h nu and momentum h nu by c. And photons of particular frequency. If a light of all the photons of particular frequency, light of particular frequency has the same energy and same momentum. Right? If frequency is constant, then energy and momentum of photons also constant. All the photons of light of particular frequency have same energy and same momentum, And the fourth point is that photons are electrically not neutral. That's why they are not deflected in the electric and magnetic fields. And the fifth point is that in photon particle collision, law of conservation of energy, energy and momentum is conserved, means total energy is constant and the total momentum is constant. Right? Have you understood? This is about summary of photon picture. And the next we are going to start very important topic, that is de Broglie hypothesis. I am going to erase. Right? You take the screenshot and note it. Have you any doubt? Till now, is it clear everything, students? You write in the chat box. Vishal, Suchita, Bhumika, Priyamato, Puneet, Sara. Are you there, everyone? Respond, please. Next topic is the de Broglie hypothesis, the most important topic in this chapter. De Broglie hypothesis. Very important topic. Very important. De Broglie hypothesis. Right? What the de Broglie said, and that is de Broglie assumed that. Okay, I will explain the de Broglie hypothesis. You listen very carefully. That is, firstly, before going to explain the de Broglie hypothesis, that we know that photoelectric effect. How the photoelectric effect is explained? By considering the light as wave or the particle. Answer, please. What they are considering? Whether light considered as a particle or the light considered as a wave. Which is correct? Based on which phenomena we explained the photoelectric effect? By considering the light has photoelectric effect means what happens in that when the light falls on the metal plate, then electrons emits. Then whether we consider in that whether we consider the light as particle or the wave. This is my question. In this, which is correct? Whether the light considered as the particle, okay, or the light considered as the wave to explain the photoelectric effect. Answer, please. Take the few seconds and give the answer. Very good. I think you are receiving my concept. Particle is exactly correct. Okay. While explaining the photoelectric effect, light considers particle. Very good. Mato and Punit and Bhumika, right? Aditi, you gave the answer. Right, exactly. It is correct. I'm going to continue. While explaining the photoelectric effect, the light is considered as the particle. While explaining the photoelectric effect, light is considered as the particle. But while explaining the interference and diffraction in the last chapter, wave optics, we consider the light has wave nature. That means light has the particle nature, light also has the wave nature. Then by combining both of them, then we say that the light has a dual nature. Light has, the final conclusion is that light has dual nature. When light will behaves like particle, when light behaves like particle, if the light interact with the matter at the moment, light behaves like particle. When light is passes through certain medium, then light behaves like wave. Like this, based on the situation, in some situations light is behaves like particles, and other situations light behaves like wave. Then final conclusion is that the light has the dual nature. This is the dual nature of light. Our chapter name is dual nature of light. Then dual nature of light or the radiation. Light is also called as radiation. Dual nature of radiation. And then what the Debroglie said. Okay, till now we concluded that the light has a dual nature. Radiation has a dual nature. Then Debroglie assumed that Debroglie is assumed. It is not practically he not proved. Okay, he assumed one thing that, okay, the important points I am going to give. You listen it here. That is the universe. The universe consists of the universe consists of matter and radiation only. In the universe, there are only two things. Okay, universe consists of matter and radiation. Only matter is there, radiation is there. Matter means what? Material, particles are there. Radiation means energy. If you will classify the broadly the universe, what it consists? Universe consists only two things. One is matter and other is radiation. Matter means material, and other one is uh, radiation. Radiation means energy, right? And one more point, that is the nature loves symmetry. Nature loves symmetry, right? Nature loves symmetry means how one will goes and other one also will go in the same manner. That means we can compare many things with the many others. Okay, how tree will go rises and it will growth, and after some days it will spoil, it will damage, and it will die. How tree will die, like that the human being also after some years they will grow and they will die. Then everything we can compare with the other things, right? Everything we can compare with the other things. That is the nature loves symmetry, right? Then according to that, these are all assumptions, right? The universe consists the matter and radiation. Nature loves symmetry. Then previously we discussed that radiation has a dual nature. What radiation has? Dual nature, right? Radiation has a wave nature, right? Radiation means light. Light has wave nature. This based on the wave nature, we explained the interference and diffraction. Light also has the particle nature. Based on this particle nature, we explained the photoelectric effect. That means light has the dual nature. Similarly, when or the radiation has the dual nature, if the radiation has dual nature, if radiation has dual nature, according to symmetry, right? Inverse has only two things. Inverse has only two things. One is behave. One is has the dual nature. If radiation has dual nature, then matter also has dual nature. Matter also has dual nature. Matter also have matter also has dual nature. What we are telling that previously radiation has dual nature. We know that already. Universe has only two things, radiation and matter. If radiation has dual nature, then automatically matter also has dual nature. Why? Because universe loves symmetry. One has two properties means then other also has the two properties, right? The universe has the two things. Radiation has dual nature means matter also has dual nature. That means matter also behaves like particle and matter also behaves like wave. Okay, when matter behaves like particles, for example, matter is there. Matter means material. Material is automatically made up of particles. There is no doubt. Matter means particle. Matter has the particle nature, right? Matter has particle nature, but matter also has the wave nature. Matter means material, right? Material also have the wave nature. This is according to de Broglie, right? According to Debroglie, what he said. According to Debroglie, particles like electron, proton, and neutron have both have both wave and particle nature. Okay, right? Electron, proton, neutron. These are the particles. They are also they have the particle nature, and they also have the wave nature. Both they have, right? The wave associated with the wave associated the wave associated with the moving particle. The wave associated with the moving particle. The wave associated with the moving particle is called as matter wave, right? Is called as the matter wave or de Broglie wave, right? What de Broglie said? De Broglie said that the matter has the dual nature. Okay, matter has dual nature. Matter has dual nature means matter is has a particle nature. In that there is no doubt. Why? Because matter is material. Material is generally made up of particles. Matter has the particle nature. There is no doubt. But the matter also has the wave nature. That is special, right? Then when matter has the wave nature means the wave associated with the matter, right? And that is called as a de Broglie wave or the matter wave, right? When the matter or the particle behaves like a wave, right? If the particle is in motion, then if the particle moves, then it behaves like wave, right? That wave is called as a matter wave or the de Broglie wave, and its wavelength is called as okay, and its wavelength is called as de Broglie wavelength, and its wavelength is called as de Broglie wavelength. Debroglie. If you have the problem and if you have the questions, please don't hesitate to ask me. This is a particle of mass m. Okay, electron. Let us consider it is moving with certain velocity v. Then it is associated with a wave. It is associated with a wave. That means when the particle moves, then we say that the wave is moving. Then it has certain wavelength also, right? The wavelength associated with the moving particle is called as the de Broglie wavelength. The wave associated with the moving particle is called as de Broglie wave or the matter wave. Right? That means matter also behaves like wave. When behaves like wave? When matter is in motion, at the moment this matter will behaves like wave, and he's find out his its wavelength also. Then according to De Broglie, he gave one formula for the matter wave at the wavelength wavelength associated with a particle of mass m moving with velocity moving with velocity v is this is the de Broglie hypothesis. He gave one formula, that is de Broglie wavelength associated with the moving particle is h by p or the h by mv. This is the formula that is gave by the de Broglie, right? This is the if m mass of particle moves with velocity v, then it is associated with a wave. That wavelength is lambda. Then that wavelength is h by p or the h by mv. Right? Till now, any doubt? If you want, ask anything. You can ask me. I'm going to erase. You take the screenshot. You listen it here that what we are telling it here. Oh, that is the de Broglie wavelength formula equation 1 from equation 1 came, and the light wavelength also we can find out. Light wavelength according to quantum theory, right? According to quantum theory, we know that light travel in the form of energy packets. Okay, then light wavelength we can find out according to quantum theory. According to quantum theory, energy of photon what? Energy of photon formula is what? Can you tell? Yes, energy of photon is E is equal to h nu. This is equation 2, right? Momentum of next energy of photon, and energy formula. Another formula is there according to Einstein equation. According to Einstein equation, energy for photon formula we can also write as mc square. If m is the equivalent mass, right? Then from this, from equation 2 and 3, both are for energy. Then we write from equation 2 and 3, we write like this. That is mc square is equal to, we write as h nu. Then from this, mc into c is we write as h nu. I want the mc, or otherwise we can do in any way you can do, no problem. Okay, mc square is h nu, and mc is equal to, we write as mc into c, we can write mc is equal to, we write as h nu by c, where mc is the momentum of photon, right? Momentum of photon is momentum of photon, right? Momentum of photon is, we got as h nu by c. How? Mc into c, we write 1 c, we can go to right side. Mc equal to h nu by c, we will get mc, we can write as a momentum of photon, that is equal to h nu by c, we can write. But we know there is a momentum h nu by c, but the c we can write as nu lambda. We know formula, c formula, speed of light formula, right? Equal nu lambda, this will cancel, and finally we are getting the equal to h by lambda. Then from this, that lambda is equal to h by p. That means this is equation 4. From equation 4 and from equation 1, equation 1 is the de Broglie assumption. He expected like that formula, but it is equal to the wavelength of the light. Okay, according to quantum theory, wavelength of light we got h by p, but de Broglie assumed this is for the light wavelength. But previously, that de Broglie gave the direct formula: particle of mass m moving with velocity v, then associated wavelength is h by mv or h by p. This is the de Broglie wavelength, matter wavelength, but this is the light wavelength. Both are equal, right? From equation 1 and equation 4, we say that the de Broglie matter wavelength or de Broglie wavelength is equal to the wavelength of radiation, right? From equation 1 and equation 4, de Broglie wavelength or the matter wavelength, okay, is equal to the is equal to the is equal to the wavelength associated with the photon, wavelength of radiation or the photon. Okay, light wavelength, matter wavelength, both are equal. Okay, right. Then according to de Broglie, next I'm going to give the some other formulas in the note. Okay, you write the side heading note. Then I'm going to give some different formulas for the de Broglie wavelength, right? If m mass of particle moves with velocity, moves with velocity v, then wavelength, then matter wavelength or the de Broglie wavelength, then wavelength associated with the particle, associated with particle. Formula is what? Tell me. Lambda is equal to h by mv, or we write h by p. Okay, this we know. Next, I'm going to erase. I am going to continue. Various formulas I am going to give for the de Broglie wavelength. Okay, this is a particle. What you got it here? This is a particle. It is moving with velocity v. Then the wave associated with this particle is this one, and its wavelength is lambda. Then its wavelength formula: if m mass of particle moves with velocity v, m mass of particle moves with velocity v, then the wavelength associated with it we got is lambda is equal to h by mv or h by p, right? But we know that in terms of kinetic energy of particle, but we know kinetic energy of particle is kinetic energy of the particle we know is t square by 2m. Then from this is the relation between the kinetic energy and momentum. Then from this, if you write, we can write p equal under root 2m ke. Then if you substitute this, then you will get the de Broglie wavelength formula. Another formula you will get. De Broglie wavelength, another formula. What is that? De Broglie wavelength formula is what? H by mv. Lambda is equal to h by mv. But h by mv is the h by p. P we can write as under root 2m ke we can write. Okay. From where you got this one? Okay, previously we know lambda equal to h by p. Then from this, in case of p, p formula we are writing, that's all. Okay, what is m here? Mass of particle. What is ke at here? What is ke at here? Ke is the kinetic energy of particle. Kinetic energy of particle. This is the formula for the de Broglie wavelength in terms of kinetic energy. And for example, if a charge, if a charge, if a charge q is accelerated, if q is accelerated by a potential v, okay, this we will take like this, where v is the potential. Then at that moment, then kinetic energy formula we know that kinetic energy equal to work done by the battery. Work done we can write as the charge into potential. We know that potential equal to work by charge. Do you know this? From this, work is equal to we write as potential into charge. Then kinetic energy equal to we write as qv. Then by substituting in above equation, right, we can write the equation numbers. It is better, I think. This we can take as continuation equation. We can take how many equations completed this one, or in the note we can consider it as one. Okay, substitute in the equation one. From equation one, what you will get? From equation one, we will get as lambda is equal to h by under root of 2m ke. But ke is what we can write? Qv we can write. Okay, lambda is equal to h by under root of 2m qv we write. Okay, kinetic energy is given by the battery. Then the battery is the kinetic energy equal to work done by the battery. Work done equal to charge into potential difference. Then if charge is electron, if electron is accelerated with potential v, then what we can write? Okay, an electron, if an electron of charge e accelerated through a potential v, then the wavelength associated with the electron, then associated with the moving wavelength associated with the electron is moving, then wavelength associated with the electron I want. Instead of charge q, right? I am taking electron. That's all. Electron is moving with the velocity v. And what is the wavelength of that electron? That wavelength formula just very simple. We write. Then we write it as 2m into, instead of q, we will get the charge e. That's all. There is no difference. Okay. Lambda is equal to h by under root of 2m ev. We write. But in case of electron, we can write the some formulas. Actually, this is equation 2 you have to take, okay? Because this is 1 in the note and this is the 2. And the next we can write, I'm going to erase. In case of electron, in case of electron, in case of electron, we know electron charge 1.6 into 10 to the power of minus 19 coulombs. And electron mass also we know, right? Electron mass also we know. Do you know what is electron mass? 9.1 into 10 to the power of minus 31 kg, right? And Planck's constant also we know. Planck's constant value is what? H is equal to 6.626. Okay, 6.626 into 10 to the power of minus 34 joule seconds. This all you substitute in above equation. That is lambda is equal to what you got from above equation, right? What is that formula from equation 2? Lambda is equal to h by under root of 2m qv, but qv we write as ev, right? Here you substitute the two m value, h value, m value, e value, all values you substitute. Then you will get, you simplify it. Then finally you will get the lambda value as 12.26 of square root of b angstroms. This v is called as potential. Electron is accelerated through the potential v. Electron is moved with the potential. When you will apply the potential difference, electron will move, right? And this is the potential. And this we can also write in angstroms to nanometers, right? 1 angstrom equal to how many nanometers? 10 to the power of minus 1 nanometers. Okay, you remember it. Then de Broglie wavelength in terms of nanometers also we can write. This is 10 to the power of minus 1 nanometer we write. 10 to the power of minus 1 is multiplied with 12.26. Then you will get is 1.226. 1.226 into square by square root of b nanometers you will get. Okay, this is the de Broglie wavelength. But this is applicable for only electron. Okay, the above formula applicable for only electron, applicable for only electron. Why only electron is it is applicable? Because electron values we wrote, electron charge, electron mass, Planck's constant, all electron values you wrote means electron only you will get, electron wavelength only you will get. That's why it is applicable for only electron. This we can take as equation 3 and this is equation 4. And the next, for example, a charge q, okay, it is an accelerated with a potential v. At the moment, the lambda formula we know is by under root of 2m qv. But here I am taking that, for example, a particle moves under the, a particle moves with kinetic energy b, let us consider, with kinetic energy k, with kinetic energy k, then ke formula in terms of temperature we write, okay, 3 by 2 kBt. Due to the temperature, if it is moving, then we write Ke formula is 3 by 2 kBt, where Kb is the Boltzmann constant. Kb value is 1.38 into 10 to the power of minus 23. Okay, joule per Kelvin. Kb is called as the Boltzmann constant. This you learned in the first year, in the 11th class, kinetic theory of gases. In that kinetic energy formula, we can also write like this 3 by 2 kBt. Okay, Boltzmann constant, where T is the absolute temperature, where T is the absolute temperature. Absolute temperature means what? Temperature measured in the kelvins. Temperature measured in kelvins. Once you can write the notes, some points you may not get the clarity. Once write the notes and check line by line, and once again, if possible, once again you can hear, 100% you will get the full clarity, right? From equation 1, what we can write here, you say, from equation 1, lambda is equal to, firstly what you got, h by e you got, then p converted into kinetic energy, that is h by under root of 2m ke we got, right? Here ke formula we got here 3 by 2 kbt. Then we write here 2m into ke formula we write as 3 by 2 kbt. This is from equation 2, I think. Is it equation 2? Lambda equal to h by under root of 2m ke. I'm not remembered. Once you can check yourself. I'm writing direct formula. Okay, right. You simplify it. Then what you are getting? Lambda is equal to h by under root of what? This 2 gets cancelled. Then 3m kbt we will get. Right? Where m is the mass of the particle, it is moves under the temperature T. That means its wavelength is V. Then according to the Debroglie, the moving particle has wavelength. It is behaves like wave. Right? Its wavelength formulas are these all things. Right? These are all called as the de Broglie wavelengths. Students, is it clear till now? Any doubt? Is it clear? Response. Write in chat box. I'm going to erase this. You take the screenshot and note it. I will give the conclusion of these all formulas at one place. Okay. Till now, what we learned that in the de Broglie hypothesis. Okay, that all I will write in at one place. Right? That is the de Broglie wavelength. Right? De Broglie wavelength. What you learned in the beginning, right? The wavelength associated with the moving particle. If m mass of particle moves with the velocity v, right, or it's with the kinetic energy ke, then at the moment it is associated with a wave, right? That wavelength is called as a de Broglie wavelength. De Broglie wavelength basic formula is h by p in the beginning. Later p we can write as mv also, mass into velocity. Later what we wrote, p we wrote in terms of kinetic energy, that is under root 2m ke. Later, kinetic energy formula we wrote. Kinetic energy formula in terms of charge and potential, that is 2m qv. QV, this V and this V is different. This V is the velocity, this V is the potential. And in terms of temperature also finally we wrote. Right, whatever that we learned, that is now I wrote in one equation. This equation you have to remember, right? And this is just by converting from one to another, you will get this one. Or how? H by p, p is mv, p formula under 2m ke also, kinetic energy formula, qv also, right? Kinetic energy formula 3 by 2 kbt also, 3 by 2 kbt, if you write it here, 2m into 3 by 2 kbt, 2 to cancel, then 3m kbt you will get, right? Okay, next one is one more important point I am going to give, right? One important point I'm going to give, that is also in the note. That is a particle of mass m, a particle of mass m projected horizontally. Particle is projected horizontally with a velocity u. One particle is projected horizontally with a velocity u. If it is, if it makes, if it makes an angle theta with the horizontal, with the horizontal, after some time, after some time, then at that instant, its de Broglie wavelength. This is one concept application, and this will become in the just it will come for the problem. I will explain to listen very carefully what we are doing it here. Okay, it was very simple concept. It was very simple concept. What I am doing it here, that one object is thrown horizontally. Okay, one object is thrown horizontally with a velocity u. Look at here. From here, I am throwing the one object whose mass is m. This is thrown horizontally with velocity u. Okay, and if it is makes an angle theta with the horizontal, now how much angle it is making with the horizontal? Initially, it is thrown horizontally. This is only horizontal, right? That means it is initially angle is 0, but now it is travel like this horizontal projectile, you know that. And when it comes to here, okay, its velocity is v now. Let us consider its velocity changes while coming down. When you throw horizontally, it cannot go like in the straight. Due to the gravity, it will fall down. Due to the gravity, it will fall down. After some time, it will come to here at this location. Now, at this location, right, the velocity making some angle with the horizontal. How much angle it is making? It is making theta angle with the horizontal, right? Now the velocity is classified into components. This side velocity will become v cos theta, and this side velocity is considered as v sin theta. What they are asking in this, after time t, right? It makes an angle theta. That object is thrown horizontally, right? It will go along this path. It cannot go in the straight. Along the horizontal, it cannot go because due to the gravity, it will fall down. While it is falling down, after some time, the object velocity is v, and it is making an angle theta with the horizontal. This line is the horizontal, this red line, v cos theta line. Okay, and now at this instant, when it makes an angle theta, at that instant you have to find out the momentum. The momentum formula is what? H by mv. But we should not take initial velocity because after some time they are asking to find out the momentum. That's why h by mv. But we not giving the data. We have to convert v into u. That's why. But we know along. But we know along horizontal acceleration is zero. Acceleration due to gravity downward will be there. Along the horizontal velocity is constant because acceleration is zero. Along horizontal velocity constant because acceleration is zero. Along horizontal initial velocity is what u. Final velocity is what v cos theta. Okay, along horizontal here velocity is v cos theta, here velocity u. Along horizontal velocity should be constant. That's why u is equal to v cos theta you will get. Okay. Then from this v is equal to what you will get? U by cos theta you will get. V is equal to u by cos theta you will get. And this is equation 2. Now equation 2 substituted in equation 1. Then what you will get? Lambda is equal to h by mv. H by mv. But v is what? U by cos theta. Then cos theta goes to numerator. Then what you will get? Can you tell? Lambda is equal to h cos theta by mu you will get. Oh, something is wrong. I think H is the Planck's constant, right? Is it right? It is correct. H is not at height here. H is the Planck's constant. H is the Planck's constant. Okay, have you understood? In the given data, they gave the data. In terms of the given data, we derived the formula for the de Broglie wavelength. This is the important formula, right? Have you understood? This will come in the problems only. In the theory, right, in NCERT book, you cannot find this formula, but you will find the problem based on this, right? And this is the application, concept application, right? Is it clear, students? Till now? Now we will go for the problems. Okay, few problems we will. Can I continue? Students, can I continue? I am going to explain. I want to explain few problems now. Right. Thank you. Any doubt till now? Puneet, do you have any doubt in the derivation in any step? If you have, you can type it. Don't hesitate to ask. Okay, right. Thank you. And now we are going to discuss the few problems. I am going to give the question, that is a proton and electron. A proton and electron. A proton and electron have, first problem. A proton and electron have same velocity. A proton and electron have same velocity. Which one has greater de Broglie wavelength? Which one has greater de Broglie wavelength? This is my question. Type the answer. Type the answer. Type the answer. Proton and electron have the same velocity, means velocity constant. Both are moving with the same velocity. V is constant. Then question is that which one has the greater de Broglie wavelength? Kindly answer. I am waiting for the few seconds. Before that, I will write one more question on the right side. You answer and you also give the reason. Why? Why you are telling that answer is correct? You can also give the reason. Second question I will write. An alpha particle and a proton are accelerated from rest by the same potential. By the same potential. Find the find the ratio of their de Broglie wavelengths. Ratio of their de Broglie wavelengths. Solution. What they gave in this? First one, alpha particle. Alpha particle mass we can take as m1. Alpha particle charge we can take as q1. Alpha particle wavelength we can take as lambda 1. Next one they give proton. Proton mass we can take as m2. Proton charge we can take as q2. Proton wavelength we can take as lambda 2. What they are asking? They are asking the ratio of de Broglie wavelengths. Right. Okay. Aditi gave the answer, that is electron. Any other member? No one is expecting. Very easy. Right. Let us go for the solution of the first one. De Broglie wavelength formula. There are many formulas are there. Based on the given data, you have to write the formula. Right. Lambda is equal to one basic formula is h by p. P is the momentum mass into velocity. Your velocity constant they gave. That's why you should take the de Broglie wavelength formula in terms of velocity. Velocity constant, Planck's constant. That means the wavelength is inversely proportional to mass. Which one has the less mass? It has more wavelength, right? When you compare with the mass of electron and proton, the mass of electron is much less than the mass of proton. That's why the de Broglie wavelength of electron is greater than the de Broglie wavelength of proton. Is it right? Okay. Mass of electron is less. Mass is less means wavelength is more. Then in the given things, that is the electron has a less mass. That's why it has more wavelength. Is it right? Electron has less wavelength. Sorry. Less mass. Hence, it has. Hence, it has greater wavelength. Okay. Try for the next one. Second question. Good, Aditi. Next question is that alpha particle. Do you know what is alpha particle? What is proton? Proton means 1h1. Proton means 1h1. Alpha particle means a double ionized helium atom. 2 helium 4. Helium plus plus actually. Helium plus plus. Double ionized helium atom. Okay. Helium plus plus is called as the alpha particle. Double ionized helium atom. Two electrons are removed from helium. That's why it has the plus 2e charge. Oh, sorry, it's mass. It is mass, not charge. Mass, what we write? This mass number you have to write. Helium mass, alpha particle means helium. Helium mass number is 4. 4 units we have to write. 4 units we have to write. And charge is the plus 2e. Why plus? Because alpha particle is the doubly ionized. Two electrons are removed from the helium. If one electron removed plus 1e charge, two electrons removed plus 2e charge, three electrons removed plus 3e charge. Alpha particle means doubly ionized helium atom, means two electrons are removed. That's why plus 2e we write. Lambda 1 is lambda 1 wavelength. Second one, proton mass. Proton mass number we have to take. Proton is 1 is 1. That's why we have to take 1 unit only. And proton mass completed 1 unit. Proton charge, proton means only one particle, plus 1 eV, right? And proton wavelength we can write as lambda 2. Then what they are asking? They are asking to find the ratio of the de Broglie wavelengths. Lambda 1 by lambda 2 is equal to what? This is our question. Then we have to take that the condition they gave in this, that they are accelerated with the same potential. Two particles are accelerated with the same potential. Electron and proton and alpha particles are accelerated with the same potential they give. Okay, same potential means potential we constant we have to write. Potential constant we have to write. If potential constant, then they are asking to find out the ratio of the de Broglie wavelengths. Lambda 1 by lambda 2 is what? Then lambda formula, potential constant they gave. That's why we have to select the formula in terms of potential, then in terms of potential formula, 2mqv we have to write. This v is the velocity, this v is the potential. In this, what is constant? H constant, 2 constant, v constant. That's why we write lambda is inversely proportional to root mq. Then this we write in the ratio form. Anybody gave the answer? No. Your pen is not working. No one giving the answer. Then we write lambda 1 by lambda 2. We write in the ratio form. That is, it is in denominator. That's why m2 q2 by m1 q1 we write. Now substitute the values. m2 is 1 into 1e by 4 into 2e. Then root 1 in the numerator, e cancel, then root 1 in the numerator, you will get as 1. In the denominator, root 4 is a 2, 1 by 2 root 2. This is answer. Have you understood, students? Let us go for one more question. I will give the homework for you. You try to solve it. I am going to erase this. Actually, today is the this network what computer laptop is not supported. That's why we wasted the time for the half an hour. Next question, the number three. Third question is what? The third question is that a proton and alpha particle, same, a proton and alpha particle. Previously also we got the proton and alpha particle. A proton and alpha, it's a homework. Proton and alpha particle accelerated, accelerated through the same potential, through the same potential. Find the find the find the ratio of their de wavelengths. De wavelengths. In the bracket they gave that mass of proton is mass of proton mp. They gave us 1836 times of mass of electron. This is the thing in the bracket they gave. Mass of proton is 1836 times of mass of electron. Same method you have to use. Okay. Here they gave the proton and sorry, little bit change in the question. Proton and alpha particle nahi hai. Oh shit. This is electron. Proton and alpha particle problem we completed. Proton and electron. Okay, accelerated through the same potential. Find the ratio of their de Broglie wavelengths. Okay. All right. And you write in the comment box answer everyone. Okay. After completion of that. Next one more question. An electron. An electron accelerated An electron accelerated through a potential. An electron accelerated through a potential 100 volts. Find the de wavelength. Find the de wavelength. Can you solve it? Which formula we have to use? Anyone can give the solution for this? Electron accelerated. For the electron, we derived the special formula. Actually, electron is accelerated to the potential. Potential they gave. In terms of potential formula, we know already that is under root 2m qv. But we substituted the q formula, h formula, m formula. We simplified, and finally we derived one formula for the electron. In case of electron, we use this formula. Is it right? 12.26 by square root of V angstroms. This is for only electron. Is it right? This formula is applicable for only electron. Here they gave only electron. Then we write here Vi is 100 volts. Then if you write the Vi is 100 volts, then lambda we will get as 12.26 by square root of V. V is 100. Then we will get as lambda is equal to 12.26 by 10 angstroms. Then lambda we will get as 1.226 angstroms. Solution is completed. Have you understood this? Then fifth question for the homework I will give. You try to solve it. The maximum kinetic energy of the maximum kinetic energy of photoelectrons. The maximum kinetic energy of photoelectrons is 3 electron volts. Oh, the battery is low. Okay, then after writing this, I will close. What is the stopping potential? What is the stopping potential? Okay, I am going to close. Thank you to all. You try to solve this problem. Okay, and write in the comment box. Okay, thank you to all.